Go to TAPgiles.com to learn dreams, engage my services, and support the channel. Something about calculators though is when you're just using the sliders, these are just individual numbers, it's all very straightforward. Let's just put on plus. But if you're not using sliders, then you can wire in a value just like with any setting. So if I can like wire in different values into here. So now it's 1 plus 0.4 and the result is 1.4. Which all makes sense. However, there aren't just these thin wires where it's just one colour going through. You can also have fat wires from different gadgets. So a trigger zone has a detected output, and if you wire that into the calculator, you can see it actually has lots of different colours because this is a fat wire and it has not just one value going to here or one value going to here. And if we like set something up, so I'm just going to have a tag and it's going to look for tags and it will just find one. So that's fine. So it's sending out a on signal and you can see it's a 1 there, but in fact it's not just a 1, it's actually lots of different values going through this wire. So if we use a splitter gadget and wire it in there instead, now we can see all those values. So it's sending a value from here and here and here and here and here and here. So it's actually got 6 values it's sending, and those can all be different values, not just one, depending on what settings you have and all that kind of stuff. So how does a calculator interact with these fat wires? So let's just delete that, and we can actually make our own fat wire with a combiner gadget. So that was from the trigger zone, that was a player info fat wire, and you can see we have those same numbers like that. But we're just going to use 2 numbers because we've got 2 value sliders over here. So if we wire that in there, wire that in there. So if we wire this into the calculator now, it's not just one colour, it's got multiple colours because it's a fat wire now. And you can see if we put those both to 1, we're getting not 1, but 1.41. This is because this is like a default value it uses. Each of the different fat wire types has a default value. So like the collision, I think the default value might be impact, and it will use that for gadgets that don't understand the collision type of fat wire, stuff like that. But for the 2 numbers and like any of these, it uses, so these are known as vectors, which just means like a list of numbers. So like a coordinate in a 2D map would be, you got like an X coordinate and a Y coordinate, for example. So that this could represent that. And then you have and a magnitude of a vector like that is how far away it is from the 0 point. So if it was like down here, it would have like 1 and 1, and then you have this distance going on over here, and that's the default value for these vector type ones. And that's what it's showing in here, 1.41. If you set it to 1 and 0, you can imagine if it's a grid from the top left, it will be 1 across and 0 down. So how far away would it be from 0? It would be 1, and that's why it's showing you 1. But it's still a fat wire, so when we add 1 to that, we're not getting out a 1, we're getting out 2.24. So, and it's a fat wire again. So it keeps the same kind of types so that you can act on all of the values coming in at once. So if we split this fat wire we're getting out of here, so we're taking this fat wire which is 1, 0 and adding 1 to it, and we're getting out this down here. So it's actually taken the 1 and added 1, and then you get that out of A. So like A is 1 and then you add 1 to it, and then A becomes 2. B is 0 and you add 1 to it, and then B becomes 1. So it's just adding to all of the values in the fat wire, as you might expect it to work. Then if you subtract 1 instead, works the same. So 1 minus 1 is 0, 0 minus 1 is minus 1. And multiply, if we put this to 2, the 1 becomes a 2, the 0 stays at 0. And divide, 1 divided by 1 is half. Even greater than, so this is a 1 and a 0. If we set this to 0.5, 0.5, then the top one is greater than 0.5, so it's sending a 1. And the bottom one isn't greater than 0.5, so it's sending a 0. And it doesn't matter what this value is, if it's greater than 0.5, it will be sending a 1 out of that channel of the fat wire. Same for equals, so we've got if you set this to 0, that one will have a 1, and the top one won't because that's not 0. And it works for all of these, so yeah, that one works. Yeah, so if you did maximum, then because 5 is the maximum out of 0 and 5, that's sending a 5, and 5.6 and 5, the 5.6 is greater, so it sends that. So you can do a lot of calculations on a lot of values, all with one calculator, if you kind of set it up right. Power of, so 2 to the power of 2 is 4, and 1 to the power of 2 is 1. So it purely does all the same things, but on each individual value, and then makes a fat wire of the same type, and outputs that. One last thing though, and that works even if you put that into there, for example. So like if you want to add 1 to all these values, you can put it into the bottom one instead if you prefer, and it's working exactly the same. But what if you have a fat wire in both? So now we've got a fat wire to the fat wire. So adding one fat wire to another. So 2.5 plus 1.1 is 3.6. 0.7 plus a negative, so it's subtracting 0.3 from it, and you get 0.4. So again, it all just makes sense and all kind of marries up. Let's try 3 numbers on the top one and display what that gives us. So on the bottom one, for combiners, if I had to put 4, for combiners, there are default values that these things have if nothing is plugged in. Normally it's 0. So you can think of it as it finds this 2 value fat wire, and it says there's no third value, and this is just a 2 number thing going on, so that will just default to 0. So then we have 0.7 plus 0 from the other one, and it just gives us 0.7 again. So it kind of does its best to figure out what it should do and fill in the gaps for you. I'm just going to use a combiner, and by default it's on the signal type, which just has a plus and minus, and it adds the plus amount and subtracts the negative amount, and it just gives you a normal number, so it's just a thin wire. But if you take a fat wire and you wire that into the positive, and then we're getting that magnitude thing. There's also another way of getting out the default value. There's a couple of different ways. So one is to use any gadget that doesn't understand fat wires. So, for example, a common one people use is a number displayer. So if we wired that into the number displayer, as you saw, it gave the 1.732. But when you take it out of there, and say we just put it into another one, then it's just a thin wire. It doesn't have that fat wire again. So it's because it doesn't understand the fat wire, it's turned it into a thin wire, which means getting that default value out. And then when you take it out again, then it sends that default value as the thin wire. Another way is to use these different wire blend modes. So if you hold L1 on these input tabs, you can see wire blend overwrite, and that's the plug symbol. If you press L1 and X, it changes it. So now it's blend, and again, and that's modulate. If you use modulate, modulate will multiply the incoming value by the value in here. But the value in here is only a thin wire. So it converts any fat wire stuff going on coming into here into a thin wire, and then uses that instead. So if we wire this result straight into here and use the modulate mode, and then we want to modulate to 1, so it's just multiplied by 1, then we get that 1.732 value. So now that works completely, and you can skip that one gadget, and that works the same. Thanks for watching. I hope you learned something interesting. Go to patreon.com/TAPgiles to learn something new every day.